Hello viewers, in today's class we are going to solve yet another important problem from definite integrals, right? So here we have a very conceptual problem from definite integrals, and here uh, we are given the value of this integral is equal to pi over 6, and we have to find the value of this limit, that is the upper limit, which is given to be k, right? So here we are given the definite integral from log 2 to k, and dx over square root of e raised to x minus 1 is equal to pi by 6, right? And we have to calculate the value of k. Now here what we will do, we'll first take this integral as I, right? So let us take I is equal to integral log of log 2 to k, and we have dx over square root of e raised to x minus 1, right? Now here what we will do, we will solve this integral with the help of method of substitution, right? Okay, so now let us take u is equal to square root of e raised to x minus 1, right? So therefore u square is equal to e raised to x minus 1, and e raised to x is equal to 1 plus u square, right? So this is the first relation, right? Okay, now let us differentiate both sides with respect to x. So we have d by dx of e raised to x, and here d by dx of 1 plus u square, right? So here we have e raised to x, and here the derivative of 1 is 0, and here we have 2u du over dx, because here we have applied the chain rule, right? And e raised to x is equal to 1 plus u square, so here we have 1 plus u square is equal to 2u du over dx, and therefore dx can be written as 2u over 1 plus u square du, right? Okay, now here we have changed the variable x to u, so let us change the limits accordingly. So here we see that x varies from log 2 to x is equal to k, right? So when x is log of 2, then we can find out the value of u from this relation by taking x is equal to log of 2 over here, right? So u is square root of e raised to log 2 minus 1, and u is equal to square root of 2 minus 1, that is square root of 1, that is 1, right? Because e raised to log of p of x is equal to p of x, right? So here we have used this relation, or in other words we can say that e raised to log of some number, say m, here the base is e, so this is equal to m, right? So the lower limit is given as log of 2, and here the base of this log is e, that is we are dealing with the natural log, right? Okay, now when x is equal to k, then the value of u is square root of e raised to k minus 1, right? Okay, so now we can rewrite our integral I as integral from 1 to square root of e raised to k minus 1, and for dx we can write 2u over 1 plus u square du, and for square root of e raised to x minus 1 we can write u, right? So here we have 1 over u. Now here u and u get cancelled, and we have integral from 1 to square root of e raised to k minus 1, and we have du over 1 plus u square, and we can take this 2 outside the integral, right? And now here we can use the result, that is integral of dx over 1 plus x square is equal to tan inverse x, right? So here we have I is equal to 2 times the integral of 1 over 1 plus u square is tan inverse u, right? And the limits are from 1 to square root of e raised to k minus 1, right? So now here we can write I is equal to 2, and here we can substitute the limits and we'll take the difference. So we have tan inverse square root of e raised to k minus 1 and minus tan inverse 1, right? Okay, so now we know that the value of the integral I is given to be pi over 6. So here we can write pi over 6, and we have 2, and here we have tan inverse square root of e raised to k minus 1, and here tan inverse 1 is equal to pi over 4, right? Now we have to simplify this expression. So this expression can be written as pi over 12, and we have tan inverse, and then we have square root of e raised to k minus 1 minus pi by 4. Taking pi by 4 to the left hand side, we have tan inverse, and here we have square root of e raised to k minus 1, and we have pi over 12 plus pi over 4, right? And now if we add, then we have 12, the LCM of 12 and 4 is 12. Here we have pi, and here we have 3 pi. This is 4 pi over 12, that is pi over 3, right? So now viewers, we have the relation, that is tan inverse square root of e raised to k minus 1 is equal to pi over 3, right? Now taking this tan inverse to this side, we have square root of e raised to k minus 1, and we have tan pi over 3, right? And tan pi over 3 is tan 60 degrees, which is equal to square root of 3, right? And now if we take the square of both sides, we have e raised to k minus 1 is equal to 3, and e raised to k is equal to 3 plus 1, that is 4. So we have e raised to k is equal to 4, which can be written as e raised to log of 4, right, to the base e, right? And if we compare both sides, we get k is equal to log of 4 to the base e, right? We can also write it as log 2 square to the base e, and k is equal to 2 log 2 to the base e, right? So viewers, the value of this k, which is the upper limit of this integral, is given by log of 4 to the base e, or 2 times log of 2 to the base e, right? So this is how we solve this important conceptual problem from definite integrals.